Okay, here you are asked to find the area inside the circle, r equals 18 cosine theta, and outside the cardioid, r equals 6 plus cosine theta. So what we need to realize is that we need to use the formula for the area of a basic polar region, which I have for you right here. Right here is the formula that we'll need to use. And also we'll need to understand that we need to, in order to find the area inside the circle and outside the cardioid, we need to subtract the area of the circle minus the area of the cardioid. Now first what I want to direct your attention to is to the graphical representation of the circle and the cardioid. So this is what it looks like. And as you see, I have it shaded in with the red lines, the area that they're asking for. And as you can see, the black dots there are the bounds that we need to find, okay? So going back to here, we need to find theta 1, we need to find theta 1, and we need to find theta 2. So how we do that first is we just simply set each equation equal to each other, and that's how we find our points of intersection or our bounds that we'll need for integration. So what we have here is 18 cos theta is equal to 6 plus 6 cosine theta. And what I did is I just distributed the x to the 1 into the cosine theta. So now what we do is just subtract a 6 cosine theta from both sides, and we get 12 cosine theta is equal to 6. Now we divide both sides by 12, and we have cosine theta equals 6/12. And that simply reduces down to cosine of theta equals 1/2. Now we need to ask ourselves, where on the unit circle does cosine theta equals 1/2? And what you could do here is look at the unit circle and find where your x value or cosine is 1/2. So that occurs, theta equals, or cosine equals 1/2 at pi over 3 and 5 pi over 3. However, because we're only looking between basically 0 and 2 pi, we can't accept this 5 pi over 3 term. So if you go back and look at the graph, this is actually, we want to look at this top black dot, which actually would be pi over 3, and we go down, and this would actually be negative pi over 3. Because if you think about it, if we went to 5 pi over 3, we would be going in this direction, and we would end up at 5 pi over 3. So again, we would end up in a counterclockwise direction, end up at 5 pi over 3. But that's not what we want. We want to go from pi over 3 to negative pi over 3. Okay? So this is actually negative pi over 3. Okay? So that's our bounds. Our bounds is pi over 3 and negative pi over 3. And that's what we'll use for our bounds of integration. So now, continue with this problem. We have, I'll just set up the integral for the circle. So we have the integral from negative pi over 3. Let's do a better job of that. So negative pi over 3 to pi over 3, and we have 1/2 18 cos It's so cosine theta squared d theta minus our area formula for the cardioid, which is the integral from negative pi over 3 to pi over 3 of 1/2 6 plus 6 cosine theta d theta. Okay, and again, we used our formulas, what we have up here for that. Okay, given our formula of a equals the integral from theta 1 to theta 2, which we found, 1/2 f of theta squared d theta. Alright, and this is what we have here. Alright, so now what we need to do is just integrate both of those, but because it will take a long time, I won't do that in this video. If you want me to show you how to integrate it in another video, I can do that for you. Otherwise, here I'm just going to get to the answer. Alright, so this is our two integrals, and again, if you want it shown how to integrate both of those, I can do that in another video. But anyway, so when we anti-differentiate both of those, we get the area of the circle, to be equal to 9/2 times 9√3 plus 4 pi. Alright, so that's what we get. And that's approximate. If you want an approximate answer, is 126.70. Alright. And now for the area of the cardioid. Oh, I'm sorry, I got that mixed up. That was actually the area of the cardioid. So let's see. I'll just go back a couple. And that's actually the area of the cardioid, which I just wrote out. Alright, so let's change that. So area of cardioid, which I just wrote out, but I wanted to write in a different color, is 9/2. Same thing as I wrote down before. √3 plus 4 pi. Which again is approximately 126.70. Okay, now the area of the circle, is, in fact, we found that to be 81/3 or 81√3 over 2 plus 54 pi. 54 pi, which that actually looks like a 9, so we'll rewrite that. 54 pi, which is approximately 239.79. And now, what is the equation that we need to find the total area bounded by this region? Well, I have that for you. Okay, I have that for you, and that's simply the area of the circle minus the area of the cardioid. So the area of the circle, which I have here, the area of the circle, subtract the area of the cardioid. Okay, so what do we get when we do that? Well, when we subtract those two from each other, we get a value of, so total area, and we get a value of 36 pi. And that's our final answer. Alright, final answer is 36 pi. Again, if you want to be shown how to integrate those, I can do that in another video. But again, this is our answer, 36 pi. If you have any questions or concerns, just comment in the comment box below the video.